Generalization set is a way to group multiple generalizations into different dimensions, making it easier to manage and organize complex classification hierarchies. Here's a deeper look into its components and uses. A generalization set may be also associated with a classifier called its power type. In addition, each generalization set has two properties: is covering with values complete or incomplete, and is disjoint with values disjoint or overlapping. I must admit that this all looks like a very complicated subject. Let's try to understand it better by looking at an example. Suppose you have a vehicle superclass. If you want to model subclasses, you can think of different dimensions such as fuel type or vehicle type. The fuel type and vehicle type classifiers describe these generalization dimensions and are called power types. Let's now add subclasses of the vehicle class given the fuel type. For example, these could be petrol, diesel, or electric vehicles. In turn, some of the vehicle types are car or truck. We have in this way created two generalization dimensions, or in other words, two generalization sets described by the fuel type and the vehicle type classifiers, respectively, but it's not over yet. Do you remember that a generalization set has two properties? We can use them to specify additional features of the dimension. The is covering property determines whether the set of specified subclasses is complete. The is disjoint property determines whether the specified subclasses can overlap. Let's talk about is covering first. For the fuel type dimension, is covering takes the value true, or in other words, complete. So the list of subclasses in this dimension is complete. There are no other ways to power vehicles. Each vehicle instance must be an instance of at least one of its subclasses, so each vehicle must be powered by petrol, diesel, or be electric. These are the only allowable options. If you look at the vehicle type generalization set, then the value of the is covering property is set to false, which means incomplete. This means that truck or car are not the only possibilities. There may be other types not listed here, such as motorcycle. Now let's talk about the second property called is disjoint. As we said earlier, the is disjoint property determines whether the specified subclasses can overlap or not. Let's take a look at the fuel type generalization set. The is disjoint value is set to false, in other words, overlapping. This means that a vehicle subclass can belong to more than one fuel type, for example, hybrid vehicles using both petrol and electric power. In the case of vehicle type, the is disjoint value is set to true, so disjoint. This means that each vehicle subclass can belong to only one category, either a truck or a car, not both. In summary, generalization sets help in organizing complex classification hierarchies. At the same time, I must admit that it is, however, a rather advanced mechanism that requires a good knowledge of UML. Let's now take a look at the different ways we can represent generalization sets in UML diagrams. This slide shows three main notations for illustrating them. First, on the top left, we have generalization sets designated by name. Here, we explicitly label each generalization with a generalization set name. Next, on the top right, we see generalization sets designated by shared target. In this notation, instead of labeling every generalization explicitly, we show that multiple generalizations share a common generalization set. This method can simplify our diagrams by reducing the number of labels. Finally, at the bottom, we have generalization sets designated by dashed line spanning generalization arrows. Here, we use a dashed line to connect the generalization arrows, indicating that these generalizations belong to the same set. This visually groups the generalizations, again avoiding the need for explicit labels and keeping our diagram clean and intuitive. Now let's talk about constraints on generalization sets. In this slide, we will take a closer look at how the is covering and is disjoint properties can be used to create constraints and what their default values are. The table contains all four possible combinations of property values with explanations. It's worth remembering that the order of property values doesn't matter. So if we write complete disjoint, it's the same as writing disjoint complete. It is very important to remember that the default values are incomplete overlapping. In other words, by default, both properties are false. If we only specify one value, the other takes its default value. For instance, if we just write complete, it's the same as writing complete overlapping because overlapping is the default value. On this slide, you can look at additional examples of generalization sets that come from the UML specification. Note the different ways they are presented and try to analyze both examples. If necessary, look at section 9.7 of the UML specification.